At first, nothing looks dramatic. That is the first shocking thing about black holes. In movies, they are often shown as glowing cosmic monsters, swirling with light and pulling everything in like giant space vacuums. But in reality, a black hole does not look like a hole at all. It is not a tunnel, and it is not a portal. It is an object with gravity so extreme that once you get too close, escape becomes impossible. And if you ever fell into one, the story would become very strange, very fast. Before we imagine the fall, we need to understand what a black hole actually is. A black hole forms when matter is crushed into such a dense state that gravity overwhelms everything else. Usually, this happens after a very massive star dies. When the star runs out of fuel, it can no longer hold itself up against its own gravity. The core collapses inward, and if the collapse is powerful enough, a black hole is born. What makes a black hole terrifying is not just its mass, but how that mass is packed into a tiny region. The closer you get, the stronger gravity becomes. And unlike most objects, the pull of a black hole changes extremely fast over short distances. That difference is the key to what would happen to you. Now imagine you are drifting toward one. From far away, you might not notice anything unusual. The black hole itself may be invisible. It does not emit light. What you would actually see is the effect it has on nearby gas, dust, and stars. Everything around it becomes distorted by gravity. As you move closer, the environment begins to change. Light bends more noticeably. Space itself appears warped. If you were in a spaceship, your instruments might show that the gravitational field is becoming dangerously strong. But the truly dangerous region is still ahead. That region is called the event horizon. The event horizon is the point of no return. Once you cross it, no signal, no object, and not even light can get back out. This is not because something is physically blocking escape like a wall. It is because the space-time inside the black hole is curved so extremely that every possible path leads deeper inward. This is where things get truly unsettling. If you were falling toward a black hole, your own experience would depend on the type of black hole. If it were a small or stellar mass black hole, the tidal forces near it would be brutal. Tidal forces happen because gravity is stronger on the part of your body closest to the black hole and weaker on the part farther away. Your feet would feel a stronger pull than your head. That difference would stretch your body vertically and squeeze it horizontally. Scientists call this process spaghettification. It sounds like a joke, but it is one of the most terrifying real consequences of black hole physics. Your body would be pulled into a long, thin shape like a strand of pasta. And, for a small black hole, this could happen before you even reached the event horizon. That means you might be torn apart before you fully cross the boundary. But not all black holes are the same. If the black hole is supermassive, meaning it has millions or even billions of times the mass of the Sun, the event horizon is much larger. In that case, the tidal forces at the horizon can be much weaker. Strange as it sounds, you might cross the event horizon without noticing anything special at that exact moment. No flash, no explosion, no sudden impact. Just a quiet crossing into a region from which there is no return. That is one of the most disturbing ideas in physics. The moment you become trapped may feel completely normal. From your own point of view, you would keep falling. Time would still feel like time. You would still see the black hole ahead of you, but you would not be able to stop your descent. The outside universe would begin to behave in increasingly strange ways. To someone watching from far away, you would appear to slow down as you approach the event horizon.
Your image would become dimmer and redder as light from you gets stretched by the black hole's gravity. Eventually, you would fade from view. But from your point of view, you would not freeze at the edge. You would continue inward. This difference between the outside observer and the falling person is one of the strangest parts of black hole physics. The two perspectives do not match. One sees you almost stop. The other sees you continue falling normally. And once you are inside, the rules of escape are gone.
You may still think of flying upward, turning around, or firing your engines. But inside the event horizon, all possible future paths point inward. It is not simply that the gravity is too strong. The structure of space-time itself has changed in such a way that moving outward is no longer a possible future. That is why the event horizon is so important. It is not just a physical border. It is a one-way boundary in the geometry of reality. As you fall deeper, the forces become more severe. If you survived the horizon, the next stage would be even worse. The tidal forces would continue stretching your body more and more. Your atoms would not remain safely together forever. Eventually, the pressure and gravity would become so extreme that ordinary matter could no longer survive in its normal form. At that point, your body would no longer be your body in any meaningful sense. First, tissues would be torn apart, then organs, then cells, then molecules. Then, even the atoms themselves would be separated under the extreme conditions near the center. And yet, the black hole is still not finished. At the center, according to classical physics, lies the singularity. This is the point where density becomes infinite and our known laws of physics break down. The singularity is not something we understand well. It is where general relativity predicts its own limits. This is important. When scientists talk about the singularity, they are not claiming we fully know what is there. In fact, the singularity is a sign that our current physics is incomplete. We need a better theory that combines gravity with quantum mechanics to understand what really happens at the smallest scales. So if you ask, what would happen to me at the very center of a black hole? The honest answer is, we do not fully know. We know the journey would be fatal. We know you would be stretched, crushed, and destroyed by the black hole's extreme gravity. We know that once you cross the event horizon, you cannot escape. But the final description of the deepest interior is still one of the great unsolved problems in science. There is another mind-bending idea here. Black holes do not just destroy matter, they also challenge our understanding of information. In physics, information is incredibly important. If something falls into a black hole, what happens to the information that described it? The laws of quantum physics suggest information should never simply vanish. But black hole physics raises difficult questions about where that information goes. That mystery has inspired decades of debate among scientists. So a black hole is not just a place of destruction, it is also a place where our best theories collide with each other. Gravity, time, light, and information all enter a region where our normal intuition stops working. Now let us imagine the moment of the fall more vividly. You are in space, the black hole is ahead of you, there is no sound, because sound cannot travel in the vacuum of space. There is only silence. The black region in front of you is not a tunnel. It is a place where light disappears. Around it, the universe bends and distorts. As you approach, the view outside your ship becomes more and more warped. Stars may appear smeared into arcs. The background light may look strange. Everything seems to lean toward the black hole as if the cosmos itself is being pulled in. Then you pass the point where escape is impossible. At that moment, there is no alarm that can save you. There is no last-second reversal. There is only the fall. The outside universe would still continue without you. Far away, time would go on normally. Stars would burn, galaxies would rotate, civilizations might rise and fall. But for you, the path ahead has only one direction. And that is the most frightening part of all. A black hole is not dangerous because it is loud or explosive. It is dangerous because it is silent, invisible, and absolute. Once you are too close, the universe no longer gives you a choice. If the black hole is small, you would likely be destroyed before reaching the horizon. If it is supermassive, you might cross the horizon first, but your end would still come. Either way, the outcome is the same: no return, no rescue, no way back. That is why black holes are often called nature's ultimate traps. They are not just cosmic objects.
They are boundaries where our understanding of reality becomes thin. They remind us that space is not empty, gravity is not simple, and the universe still holds mysteries far beyond human experience. So if you ever ask, what happens if you fall into a black hole? The answer is both simple and terrifying.
You would be stretched by gravity, torn apart by tidal forces, trapped beyond the event horizon, and ultimately destroyed by a region of physics that we do not fully understand. And yet, black holes are not just symbols of death, they are also windows into the deepest questions in the universe. What is space really made of? What is time? What happens at the edge of reality? And what lies beyond the limits of our current science? That is why black holes fascinate us. They are the most extreme places in the universe, and they force us to confront a truth that is both humbling and exciting. We do not know everything yet. We are still learning. And somewhere out there, in the silent dark between the stars, black holes wait with answers we have not yet found.